Hi guys, today I want to discuss the derivatives of trigonometric functions. So here are some notes that you need to take down. So the derivative of sine x is cosine x. The derivative of cosine x is negative sine x. And then you need to know the derivative of tangent x, and that's going to be 1 plus tangent squared. So what do you think the derivative of cotangent x is equal to? That is negative 1 plus cotangent x squared. And then the derivative of secant x, and that's secant x times tangent x. So based on that, what do you think the derivative of cosecant x? That's negative cosecant x cotangent x. So notice this pattern. Whenever you have a trig function that starts with c, in the derivative they all have negative sign. And that can help you to remember the derivatives of these 6 trigonometric functions. So if you know the derivative of sine, tangent, and secant, you can easily remember the derivatives of cosine, cotangent, and cosecant x, looking at the similar relationship between what you see on the left side and what you see on the right side. So what about this one? What is the derivative of 4 sine x minus 7 tangent x plus 5 cosecant x? All we need to do is differentiate each one separately. So the derivative of 4 sine x will be 4 times the derivative of sine x, which is cosine x. And once we differentiate the sine, we need to differentiate the tangent. So the derivative of negative 7 tangent x is negative 7, 1 plus tangent squared. And we said that the derivative of cosecant x is negative cosecant times cotangent x. So the final answer is going to be for cosine x minus 7 tangent squared minus 5 cosecant x times cotangent x. So that's how you find the derivative of trigonometric function. Okay, now let's talk about the derivatives of exponential functions with base e. So I hope you know what e number is. It's a natural number that starts with 2.7 and it goes on like forever. So now we know what e number is. So here's the formula that you're gonna find useful. The derivative of e to the u, where u is a function of x, is e to the u times u prime. So for instance, let's say we want to find the derivative of e to the x. So it's gonna be e to the x, so u is x times the derivative of x, which is 1. So the answer is gonna be just e to the x. So based on that, what do you think the derivative of e to the 7x? Go ahead and try that. So it's going to be e to the 7x times the derivative of 7x, which is 7, and the final answer is going to be 7 times e to the 7x. Now, let's work on some more examples. Try these 3 examples. Using this formula, what is the derivative of e raised to the 9x plus 8? The derivative of e to the x squared, 9e, 8e to the x cubed. So for the first one, it's gonna be the same thing, and then times the derivative of 9x plus 8, which is 9. So it's gonna be 9e raised to the 9x plus 8. Okay, for the second example, it's gonna be the same thing, and then times the derivative of x squared, which is 2x. So the answer is gonna be 2x times e to the x squared. So for the last one, it's gonna be what we started with, times the derivative of x cubed, which is 3x squared. So that gives us 24x squared e to the x cubed. Next, let's talk about finding the derivative of logarithmic function, particularly natural log function, ln u. So here's the formula. The derivative of ln u, where u is a function of x, is u prime divided by u. So using this formula, let's say we want to find the derivative of ln x. So u is x, and the derivative of x, which is u prime, is 1. So the answer is 1 over x. For the next example, let's try to find derivative of ln x squared plus 6. So in this case, our u is x squared plus 6, and the derivative of x squared plus 6 is 2x. So the answer is going to be 2x over x squared plus 6. So for the sake of practice, let's try to find the derivative of 4 times natural log of 5x plus 4. Okay, in this case, our u is 5x plus 4, and u prime is 5. I hope you remember the derivative of any constant is always equal to 0. So the derivative of 5x plus 4 is only 5. And we have number in front of the natural logarithmic function. So we must multiply this number here. So 4 times 5 is 20. So the final answer is going to be 20 over 5x plus 4. So that's how you find the derivative of logarithmic function. The next thing we need to talk about is the product rule. So the best time to use product rule is when you have two functions multiplied to each other. Let's say u and v. So here is what you need to do. You will differentiate the first one and leave the other one alone. And there's going to be plus, and we will leave the u the way it is and differentiate the second one. So the derivative of u times v is u prime times v plus u times v prime. So using this formula, let's try to find the derivative of x cubed times cosine x. So our u is x cubed, our v is cosine x. So u prime, the derivative of x cubed is 3x squared. V prime, the derivative of cosine x is negative sine x. So using this formula, it's going to be 3x squared times cosine x plus x cubed times negative sine x. Now, let's try another one. So what is the derivative of x squared times ln x? So in this case, our u is x squared, our v is ln x. So the u prime, the derivative of x squared is 2x. V prime, the derivative of ln x is 1 over x. So u prime is 2x, v is ln x, plus u is x2, and v prime is 1 over x. So we can simplify this, and we can write like this: 2x times ln x plus x. And you can factor out the GCF, and you can take out x here, and it's going to leave you with 2 ln x plus 1. So that's how you use the product rule. So if you want another examples, another topics, feel free to chat, and I will be happy to respond with. And if you have a question, write a comment below, and don't forget to like my page. And
it's the moment.